27th of June, this afternoon, we will have more in-depth discussions and presentations about the varied applications of PGM. According to data published by WPIC in 2023, demand from the fiber or glass fiber industry for platinum will grow 55%. So our next speaker will give you a deep dive into that. Our next speaker is Mr. Zhouli, who is the Deputy General Manager of Sinoma Science and Technology. He's going to talk about the development of fiberglass industry and the platinum applications. The floor is yours. Ladies and gentlemen, dear guests, good afternoon. Well, I am really happy to be invited by the organizer to attend the 2023 Shanghai Platinum Week. I am from Nanjing Fiberglass Research Academy, so my topic will be the development of the fiberglass industry and the applications of platinum. Well, a lot of people might not be familiar with glass or fiberglass. In particular, 20 years ago, you only had an idea of glass. In particular, glass is sort of cheap, which makes it feel as if it's totally different from PGM, which is a precious metal. So please allow me to give you a brief introduction of fiberglass. Fiberglass is known in our industry as a qualified powder that's blended from various types of ore, and it has gone through the Zhouli process. Well, it's also known in some to some laymen as being capable of being drawn to something as thin as your hair, but it has a lot of very good performance and properties such as non-combustibility, high temperature resistance, electric insulation, high tensile strength, and good chemical stability. It can be used as a substitute for steel, wood, and cotton. It's used extensively in such industries as construction, electronics, transportation, oil, chemicals, petrochemicals, machinery, environmental conservation, and is seeing increasing application in a wider scope of areas. What does it look like? As you can see, the fiberglass has the form of a yarn or fiber as well as cloth. It can be divided as alkaline-free glass fiber, medium alkaline glass fiber, as well as special glass fiber. So please allow me to give you a walkthrough of all of them. Fiberglass was invented as early as 1938 by Owen Corners, the American company, and back in 1950s, America was the first to achieve scaled production of fiberglass. Moscow, Britain, France, and Germany, as well as other advanced countries, invented varied types of fiberglass products. China is not an early comer in this area. It was only born in China in the 1950s, and the system was laid down in China in 1968. After decades of development, however, China has achieved catch up, and currently China is already a leader in fiberglass industry. Mainly, the industry in China has gone through three stages, with the first stage starting from 1958 to 1988, started from zero, and the second stage started from 1988 to 2008, and China successfully achieved number one in terms of production, use, and export of fiberglass in the world. And the third stage started from 2008, and currently we started to achieve scale production in a more structured manner. Some of the key milestones are listed here, with the first milestone happening in 1948, which marked the birth of a fiberglass industry in China. In 1958, the industrial system of fiberglass was established in China. In 1964, China's only research institute focusing on the study of fiberglass was founded, which happens to be the academy where I'm from. So the Research work done by the Academy has made tremendous contribution to China being a leader of fiberglass in the world today and laying a solid foundation for China's industry and manufacturing in general. Similar to a lot of different types of manufacturing segments, fiberglass has gone through the stage of catching up by importing. So as early as 1988, the first production line of fiberglass was brought in from Japan, and it landed in Zhuhai city of China. Chinese highest leaders paid a visit to the production line as they really paid a lot of attention to fiberglass production. In 1997, China started to design and produce on our own. In 2004, we started to achieve scale production at 10,000 ton level. That was back in 2004, 60,000 tons of capacity was the ability back then. In 2007, 2006, some technological breakthroughs were marked. In 2007, Zhouli Group, for the first time, was able to scale its production capacity beyond 100,000 tons. In 2007, China actually had the capacity of producing 1.6 million tons of fiberglass, making it number one producer in the world. And then China started to rise to number one in terms of the production and export of fiberglass. Some famous Chinese fiberglass companies started to expand their presence globally by establishing factories and offices and branches globally. So the status quo of the industry, as you can see from this chart, most of the production is concentrated in Asia and North America, or to be more specific, China and United States. China now has the largest capacity of producing 8.8 million tons of fiberglass. And for China, most of the production capacity are in the eastern part of China, represented by the capacity of Zhouli and Taishan, as well as the CPTIC. They represent they are among the top 4 producer of fiberglass in the world. Taishan, Zhouli, and CPIC. Well, as you can see from this chart, the top players of the industry now produce more than 55% of the total fiberglass in China. Taishan, Zhouli, and CPIC, they have become an oligopoly, or there is sort of oligopoly competition amongst the three. In other words, we see increasing concentration of fiberglass production capacity in China, and going forward, most of the new capacity will move to northern part of China as well as northeastern part of China, as they have quota for energy and they have other advantages in terms of the lower cost of raw materials and natural gas. So the natural shift to northeastern part of China and the northern part of China for producing fiberglass happen in the future. China is already the world's largest producer of fiberglass, so we account for over 60% of the total supply of fiberglass globally. However, our research institute has done our research, has done our statistics, and we believe that China supply far more than 60% of fiberglass. Then I'm going to talk about how fiberglass is related to PGM. Fiberglass has gone through 4 stages in the process of production in order for it to turn from solid to liquid all the way until it becomes as thin as silk. So PGM plays a very important role in that it provides a platinum-based leak board. So as you can see, be it one-step drilling or two-step drilling or direct drilling, platinum and rhodium alloy are used in all 3 different types of technological pathways as a container. In the process of producing fiberglass, mainly platinum are used in the form of a platinum-based leak board, accounting for 95% of the use cases. So it is fair to say that in our industry of fiberglass, the alloy of platinum and rhodium accounts for 30 to 50% of the total production line. And in the past 2 years, when rhodium was high, when rhodium price was high, investment of platinum and rhodium accounts for as high as 70% of the total investment in the production kiln. So it's very high.
So I would say that PGM played a very important role in our industry. And the bushings could vary from 200 holes to 4,000 holes. So the 200 holes will be 3 crucibles, while if it's a tank furnace, then it would have 4,000 holes. And for the large-scale companies, they mostly acquire the tank furnace of 4,000 holes, and the weight of the bushings would also range from 500 grams per furnace to 15,000 grams per furnace. And the materials will mostly be platinum and rhodium alloy. And the composition can be different. It can range from platinum rhodium 7 all the way to 25. And if it is a specialty material, then the rhodium content will be 20% or even more. And we have now adapted the digital simulation in designing the bushings for a tank furnace, which is a leading technology industry-wise. And so far, we have achieved the automation in the manufacturing of the equipments. In our production, we can see that PGM plays an important role, and it consumes a lot of our investment. So we also tried other materials, especially some cheap metals, to take the place of PGM. We have made some experiments like the nickel chrome alloy, use a nickel chrome alloy as the container. We tried this, but it didn't work. It is because the nickel chrome alloy, when it's made into bushing, the heat radiation is very high, so the nickel chrome is not able to withstand this extreme environment, and it's not able to produce the satisfactory products. And later, we want to try iridium, maybe use the platinum iridium alloy to take the place of the platinum and rhodium. In the North China, in a cluster of crucibles, they tried this solution as well, but the solution didn't work either. It's because in the climate, in the ambient, then the platinum and iridium alloy is pretty similar to the platinum and rhodium. But when it's up to over 1,000 Celsius degrees, then the iridium will vaporize, and the vaporization speed is 300 times that in ambient. So the bushing will lose its effect, and the whole process will fail. So the mainstream solution is pure platinum or the bushing with low content of rhodium. What we do is we will add micro elements like zirconium and yttrium to make the alloy. So with these micro element, it is able to produce a lattice that's distributed evenly in the bushing, so that can avoid the growth of the platinum crystal particle and the creep deformation. So in our institute, and also together with Harris and Obis Corning, these business players have developed some new solutions, which is being rolled out to the industry as well. So now let's look at the consumption volume of the platinum in our industry. Well, in 2022, the fiberglass production amounted to 6.8 million metric tons. If we are to have a 100,000 ton production line, then it would need 1 to 1.2 metric ton of platinum and rhodium alloy. So far, we have absorbed in our industry 68.7 to 82.4 metric ton of the alloy. Also, our counterparts in these industries are looking at other solutions, as I've mentioned, to take the place of rhodium content. So crucible companies, they can successfully replace the rhodium in their alloy. But if it is a company using the tank furnace, then they will be very slow taking the place of rhodium in their bushing. As far as I know, still many companies, especially large companies with a large-scale production line, have hundreds of kilograms of rhodium. They are trying to get rid of it as well. The market prospect for the rhodium the second half of this year is not good. That's why people or companies would tend to sell it out on the market in the second half. After the 14th five-year, according to our order prospect, every year the invested capacity of the fiberglass will still be higher than 1 million metric tons. In terms of bushings, the waste and wear and tear would amount to 10%, a little bit over 10% of all the bushing production. So anyways, in the future, we predict that the additional platinum would require for 13.4 to 16.1 metric ton per year to make the bushing. So if we look out into the future, the policies is standing behind us. For example, guided by the carbon peak and carbon neutrality policies, there will be a lot of application in the new energy using PGM and using fiberglass as well. The central government, the municipal government, and the administrators at all levels are making all kinds of policies and regulations to try to encourage the development of the new energy technology. Well, the application, most of all, is in the automobile and transportation. Well, it takes still a long way for Chinese material companies to get the dominant position in the automotive industries. So the domestically made fiberglass, only takes about 30% to 40% of the total market share of China's automotive markets. So there is still room for us to grow. Well, in terms of the future market prospect of fiberglass, well, we have identified these few trends. One, green and low carbon. Well, this is the most important trends. In our industry, we are also developing the low carbon material and ingredients. We are also developing the technologies to improve the efficiency of the hydrogen furnace. We have made a breakthrough in the hydrogen power furnace. Our institute has also taken the research project of the fiberglass application in tank furnaces. Under the backdrop of low carbon economy, or PGM will enjoy strong demand, because if we are to reduce the emission, if we are to improve the energy efficiency, then the bushing will be much bigger and there's been more holes. So in this structure, the PGM will be used more. Also, we are looking at the possibility of reinventing or evolving the application of PGM in the bushing. Or rhodium, our point of view is rhodium's demand will fluctuate according to its own price. If the rhodium price is less than 500,000 RMB, then the industry will again buy in the rhodium, because the rhodium did enhance the performance of the bushing. So the alloy of platinum and rhodium will generate the best performance, which is a consensus of the industry. Okay, I'm running out of time. I have to end here. Fiberglass is developing fast. It's a new material. It got the encouragement from the policy and the government, but the application is still at an early stage, and we're still expanding this demand in the lower stream. And anyway, the platinum will play an even more important role as our industry grows. Okay, this is all of my presentation. Thank you.